Welcome to this last session for the Micro-frontend Summit. As I said, I'm very excited to be here. I'm going to talk about a topic that I covered probably with such a large audience just once, so this time, and I hope that you're going to enjoy. Last year, I think it was around January time, I started to think a bit about micro-frontend. So what we are missing, where we are going, what are the experience that I have gained in the last few years, what we can do better. A sort of retrospective and thinking about what was the next step. And one thing that I realized very quickly is that we have done a fantastic job in the micro-frontends community, creating some, let's say, opinionated or less opinionated framework for helping to solve quite common problems, like how you compose your micro-frontend, how you're going to communicate with micro-frontends. But there is one challenge that I believe we didn't tackle properly. And that is the discoverability of micro-frontends. And we will see in a moment what I mean for that. My name is Luca. I'm an AWS Principal Serverless Specialist. I'm an international speaker and a book's author. I think that is more than enough for me. Let's dive in into the topic. So let's start first with the definition of micro-frontends. Why that? I know that by now you should have understood perfectly what micro-frontends are. But one thing that I have seen in hundreds of conversations that I had in the last few years with customers is that the people often are thinking about micro-frontends in the wrong way. And if the starting point is not correct, how can be the outcome? Let's start with this. So this is a definition that I, let's say, defined quite a few years ago, but I think it still resonates well. So micro-frontends are a technical representation of a business subdomain. They allow an independent implementation with same or different technology. They minimize the code share, and they're owned by a single team. So as you can see in this definition, there are quite few keywords that are highlighted. And I would like to deep dive with you in each of them just to define the characteristics that we are looking at when we think about micro-frontends. So let's start with the first one, representation of a business subdomain. I know that for front-end developers, very often the concept of business subdomain might be obscure. And trust me when I say it's not only for front-end developers. It's coming from the idea of domain-driven design, where we are looking at dividing a system with the business size and slicing it in multiple chunks, because it's easier for resonate about that, but also because you can take that and then start to assign it to specific thing when you start to break down the big complexity that is in front of you. Now, one of the challenges I've seen very often with customers is when they talk about micro-frontends, they overlap the concept of micro-frontends and components. And they give you a very specific way to understand the difference. When we think about the component, let's take the most, let's say, simple example, but I think it should be exhaustive enough to understand the difference. When you think about a button, for instance, a button can have I don't know, a label, can have an icon, let's say, I don't know, have animation when you roll over and you want to control that, you can enable, disable, and so on. And when you think about the button, you take the button and you start to instruct some properties and how they works. Now, suddenly you realize that someone else is, let's say, explaining the button how to behave, and that someone else is usually the container of the button. Now, with micro-frontends, usually you don't have to do that. Micro-frontends are, let's say, encapsulated in a way that they know how they need to behave. They might need some context, usually 1 or 2 parameters, not much more, but then they know exactly how to behave. There isn't a leak of their business domain outside the boundaries of your micro-frontend. That is a first key characteristic for understanding that and for designing them properly. That leads also the fact that micro-frontends are independent implementation. Therefore, what it means is when I design one micro-frontend, I don't have to coordinate with other teams every single time in order to deploy them. I can take the micro-frontend as a team lead or team and start to deploy in production without the need of every time coordinate with other people. The moment that you find yourself doing that, it's time to go back to the whiteboard and understand if the design respect properly the things, because bear in mind that what is the system of today that we are designing our micro-frontend for the first time, it won't be the same in 6 months time. As the business is evolving, your architecture has to evolve with the system, and also your organization structure. These three things are going hand in hand. There is no way that you can detach them or decouple them. So it's very important that you recognize the fact that it's a living system. It's not, I do the design once and then I forgot about that because it's going to work. The other thing is I've read several times in the community that micro-frontends are a way to create a fantastic playground for developers that they can use whatever technology they want. Now, I have a naive thinking where I believe we are writing code for the sake of creating value for our customers. And if you agree with me, and we're not here just for playing with frameworks, probably you should avoid to optimize for different technologies. Now, I had customers that they have done that because for them was important, for better or worse. But in general, as a rule of thumb, I would discourage you to have multiple frameworks and try to stick with one. There are situations where having multiple frameworks might help the transition from a monolithic architecture to a micro-frontend one, or when you have a legacy system that you want to migrate with, instead of having an old framework to a new framework. So for a certain period of time, you're going to penalize your customers performance-wise. However, that should be time-boxed. And that should also lead to the fact that if you design properly your micro-frontend implementation, you are generating value since the first one that you are pushing in production. The other thing is that probably the most controversial part of this definition is the minimize the code share. Now, in microservices, so the distributed system that we all know on the back end, very often we refer to them like a share nothing architecture. Now, I don't want to say that has to be, let's say, a share nothing architecture, but what I want to highlight is the fact that there are certain things that has absolutely is absolutely important to minimize, to share the code, and some others that they don't. And the example that I usually think about is a logging system, a design a logging library design system are perfect examples that should be shared across micro-frontends. But at the same time, there are certain decisions that the moment that you start to share, it means that you need to create governance around that. And that we usually forget about that, especially if we're coming from a monolithic code base where, oh, I can move from this code to the other code, change this, change there, and so on and so forth. Now we are working distributed system. If we want to maintain the independence of the team and the speed of delivery, then we need to think end-to-end how our decision of abstracting a portion of the application might impact other teams. And last but not least is the ownership part. When you assign a subdomain or a micro-frontend or multiple micro-frontends to a team, that team should own it end-to-end. What I mean is, it's not just I write the code and I've thrown on the other on the other side of the fence for let's say building some application on deploying an application in production, but we are instead owning the development, the observability, and the debugging, and etc. So other teams can contribute to the micro-frontend. However, what I encourage is to have a team that is responsible for the final outcome of the micro-frontend. Now, the problem I have seen in the last few years with in general with front-end application is this one. So when you have a single page application, let's take this one that is probably one of the simplest one. I take my single page application, I publish that into production. For better or worse, I have a bunch of static files that are, let's say, deployed in production and easy to conceptualize. But when we move to the micro-frontends world, it's completely different. Now I have multiple static files, potentially, if we're talking about a client-side rendering micro-frontends implementation. For server-side rendering, different challenge. Today, we are going to cover the client-side rendering one. And these static files will has to be deployed in production. But now we don't have just a bunch, we just have a few of them from a single page application that they are either loaded or not loaded on the client side. We are going to have multiple of them because we have multiple micro-frontends. And that can be a challenge because now suddenly from one CI, you have multiple CI that you need to span, and you need to create a way that they are running in parallel, they're running with performance, because the CI at the end is a feedback loop that you provide to your developers. If it's slow, it means that they will try to find a way to overcome the slowness of the common practice, and they're trying to figure out a way to get into their favorite environment as soon as possible. Now, for me, an investment in CI/CD is a mandatory thing. I don't even start to write a line of code if I don't have a rock solid CI/CD that I will iterate and I check that the CI/CD performances will maintain the same performances overall during the full life cycle of the project. Now, the other thing that I noticed is that vast majority of the customers that I spoke with, and we're talking about tens of customers worldwide from New Zealand to Silicon Valley, all of them, they are deploying micro-frontends in a big bang fashion. So that I create my micro-frontend, deploy in production, 100% of the traffic there. There are better ways to handle distributed system, especially when we have a lot of moving parts like this. So let's first talk about static versus dynamic import. So I will take as example two main or most famous framework that I have seen most used for micro-frontends. There are single SPA and module federation. So if you look at the single SPA, vast majority of the time, the example that you're seeing are exactly like this one. So you have an import map that is a collection of micro-frontend and libraries that you need to use in order to load your application. And then you have an import maps that can be either an native import map or a system.js import map. And there you're going to describe everything that is needed. This is living obviously in your HTML page, and off you go. On the other side of module federation, many examples are looking like this. So you have like your module, you define in your Webpack config file, your module federation remotes, and you define what you want to expose. If there is something to expose, you define what is shared, you define if it's a singleton or specific version of a library, and so on and so forth. That is what we are using, usually see in example and so on. The problem is when we are dealing in real environments, it's a challenge dealing with that. And I've seen every kind of workaround, from Chrome extensions that are intercepting the request or are, let's say, overriding the URL, to, let's say, having tools like chars or network tools that can intercept the request and change the request dynamically. But can we do something better? So the question is, how can an application shell, so a container that could be on mobile, that could be on web, is referring to a specific micro-frontend dynamically? That's the real question. So I'm a big fan of software architecture. So one of the things that I love the most is talking about software architecture. I could do that for hours and hours and days, and I don't get bored. Probably the other people get bored, but I don't. One of the patterns that could help us to solve it is usually is already solved this problem on the microservices level, because they have exactly the same problem. That is the service discovery pattern. And the service discovery works very simply. So you have like a bunch of consumer, in this case, the products, shopping cart, pricing, and order microservices that are, when the infrastructure is provisioned, they register themselves in the service registry. And what they tell them is, this is my IP and this is my ID. So if someone has to call the product microservice, like in this case, the client doesn't straight call the product microservice. There is, let's say, another service that is calling first the service registry, saying, I need the IP of the product, and then product microservice, and then we retrieve the IP and send the call directly to the product microservice. Now, this pattern allows us to change the underlying microservices implementation in the way that I want, as long we respect the contract that is ID IP. If I have this, then I will be able to call wherever I want, and I can evolve my system in the way that I need. It's exactly what we need on microservices. The other cool thing is that if we are able to implement something like that, then the discoverability of new version becomes a breeze. And also, because we are basically creating a mechanism that allows us to retrieve dynamically the endpoint, the URL of our micro-frontends, we can also use different patterns for deployment and de-risking the deployment. So I can, as we will see in a moment, let's say drastically the risk that someone is deploying a version that maybe has some bugs and I cannot know till I arrive to production, for instance. Last but not least, because it's dynamically loaded, I can also think about fallback alternatives. So the classic in microservices is called circuit breaker pattern. So at some point I call it, but it doesn't respond to the service that I'm calling. So I start to take a step back. But what we can do for mimic something similar is, if I cannot find after a couple of calls my micro-frontend, I can provide another stale data or different micro-frontend, or even hiding the micro-frontend nicely behind the scene without degrading the user experience. So how we can de-risk the deployment? But there are two very well-known approaches: blue-green deployment and canary releases. What does it mean? That if I have my traffic that is going to catalog 1.2.1 and all the live traffic is going to this version, and I deploy as a developer the new version, catalog version 1.4.0, the traffic from a live perspective, it won't go to 1.4.0. What I can do, though, is having, as a developer, testing in production my new micro-frontends without affecting the live traffic. Great. So I can understand if everything is work. Could be a developer, could be a QA, whatever you're doing. And when you're happy with that, you switch 100% of the traffic towards the new version. Bear in mind that the old version is still there, so you can even roll back as fast as you can think, because in reality is just shifting traffic between versions. The other approach is canary releases. That is similar, but different to a certain extent. So here, the cool thing is, because I have catalog 1.2.1, what I want to do is testing real traffic for a certain percentage of my traffic. So I want to test 33% precisely that is going into 1.4.0. And when I'm happy with that, I can decide to ease the traffic more or less based on the output and the dashboard that are telling me what should I do. Now, what I thought is, okay, this is not a problem that is regarding just me. It's a problem that is regarding the front-end community. So let's try to speak with the front-end community and try to figure out what we can do. So I created this working group with Joel, that is the creator of a single SPA. Matteo is a colleague of mine in AWS, but he's also the creator of Open Components. And last but not least, Zach, that probably everyone knows here, superstar on social on Twitter, and also the creator of Module Federation. And the four of us starting to think, how can we solve this problem in a way that could work everywhere? So how to implement all these features in an application shell? So we thought a lot about that. We started thinking, let's create plugins, let's do this, let's do that. The reality is I was quite let's say, convinced that the reality, we need to have a lightweight solution that will enable the community to do wherever we feel is important for them and for their company. Therefore, we thought to design a JSON schema. Why a JSON schema? But JSON is used by everyone, right? So you can think about this approach as a way that you can extend it and think properly about, let's say, the evolution of this solution. So we started with the idea of creating a JSON schema. Here you can see how we can describe a micro-frontend. We have a unique identifier of the micro-frontend. So the first is @project/micro-frontend. So at AWS Project Z, you have /catalog, that is our micro-frontend. And then what we have is a URL of the micro-frontend and URL for the fallback as entry point. You have also a metadata object that contains integrity and version. And then you have extras, because what we were thinking is, if we start to create a schema that is too opinionated, and there is one section for single SPA, one section for module federation, and then we want to do one for TypeScript and one for JavaScript, it becomes very complicated very quickly. So we said, okay, for the first release, let's try first to understand what the community wants. Let's try to be light and create an extras object where you can add wherever you need. If you want to use TypeScript, there was a comment, an issue that was open a couple of weeks ago on GitHub, where they were saying, oh, I would like to have this the flag for TypeScript, or this property for TypeScript. True, but you have an extra, let's say, object currently you can use for doing exactly that. Let's see the adoption, and then let's discuss if we can add inside the schema. But how can we introduce with something like that blue-green deployment and canary release? I didn't mention that these IDs, the micro-frontend is described as an array of objects, and therefore we can have a list. And in this case, I can have multiple micro-frontends described with under the same name, so under my account. So I can have my account 1.2.2 that has a deployment strategy that is 30% of the traffic is not a default version. Therefore, 30% of the traffic is going to this part here. And then I can have, traffic. And the default one is basically, if for any given reason you don't want to assign a traffic, you can use the default one to say, yes, go 100% to the default one. If you don't find the fallback and you don't find the micro-frontend, you go to the default one. Or if for any given reason you go over 100%. And the other one is on the bottom, that is AWS account 2.0.0, and it has a different deployment. Now, this approach is very simple, but it allows you to achieve what we are talking about. In fact, back in 2019, I was doing a talk as a customer of AWS when I was VP of architecture for a company called The Zone, on explaining how we implement something similar to what I described in the JSON schema on the edge. So we were basically using Lambda at the edge for redirecting the traffic towards a version or another one of our micro-frontends, and even for strangling the old monolithic architecture. As you can see in this link, there is a full talk. From half of this link onwards, I will explain how we have done that. The beauty of this, that for me is key, is the behavior that I've seen in developers. And we were talking about tens of front-end developers who were working with this solution. And we moved from 4 or 5 deployment per month to tens of deployment per day. And that was, for me, mind-blowing. So the benefit of this approach is that, first of all, can work from front-end and back-end. And that's not surprising. And why I'm saying that? Frontend could be a surprise, but in reality it's not. As you can see there, I pitched this idea to an ex-colleague of mine that is passionate as me about micro-frontends, and he spent an evening designing this, and then he sent me the picture. So basically the idea is, if you have enough clients that are using this technique, and you store on the client side this idea of canary release and blue-green deployment, it's very likely that a certain threshold, you are going to have, let's say, a very close number to the one that you want to shape your traffic. That is brilliant if you think about that. Then obviously there are some security implications, but potentially it works also on front end. It's not very opinionated. We're not saying, oh, you need to use this plugin. I always struggle with opinionated solution because unless it's a framework, I want to embrace fully the JavaScript community and all the great and awesome things that they are building. It's very extensible. The other thing that I wanted is having a solution that you can plug into an existing API. Very often I've seen single page application. The first thing that they do, they call an API for understanding how to configure themselves. And I wanted to do something like that. It provides the basic plus some framework specific things. Can be translated into an import maps if you want, because you can have like a service that is translating this into something else. It can be integrated in existing APIs. As a pitfalls, we identify a few things. First, you must get this configuration before load anything else. Now, we thought that is less than a problem because in client-side rendering is quite common, but at the same time, it has an impact, despite very, very small, in your, let's say, way how you're loading things, because you will load the HTML, load the first JavaScript, call the API for retrieving this configuration, and finally load your micro-frontend. It might be too loose. We are not too prescriptive. So for some people, they might find that it's a bit loose. And last but not least, for security and performance reasons, we highly encourage to use a backend solution to serve this schema. Now, the schema is actually available for a while. We didn't do too much advertising around that, but it's actually available at this link. Here you can open an issue, you can contribute, and there is the more explanation on how you should use it. But that's what we have done last year. Now, the next question is, how can we facilitate adoption? It's a nice idea, right? So there is solving many problems that can be applicable not only on client-side rendering micro-frontend, it can be applicable on server-side rendering micro-frontend, it can be applicable to any single type of front-end development that you have out there. Now, how can we facilitate the adoption? So when I started to think about that, we need to create something that is really, really tiny, that does one thing only, that is serving the ID of the micro-frontend. So what I did is creating this mock library, vanilla JavaScript, that I'm rebuilding right now for writing a better, decent way. This one is just a proof of concept to prove that it was working. And in this case, what you have is a micro-frontend discovery library that you pass the configuration, so the endpoint of your JSON, and it will fetch for you this stuff, and then you can request discovery get, and you pass the ID of the micro-frontend you need, and suddenly you have the URL of your system. You can also have a list in the case that you're using an import map. So you have a list of micro-frontends or other things that you need to pass, but you have this thing ready for you. Also, I was thinking, okay, so instead of loading just once in the application shell the configuration, I might want to create a routine, but I cannot just say, okay, let's fetch these API every few seconds. Maybe there are different, let's say, way that the customer wants to use it. Therefore, I just created this setConfig that basically does exactly the same thing of the initialization, but in reality is meant for if you want to create like a set interval or other ways, like you want to react to a specific signal that is coming from your application shell, you will be able to retrieve this information very quickly. Now, would it work in the real world? It's all very interesting, but how it can work. So the idea is this one. We said that we encourage to do that on the backend. So this is how it's going to work. The application shall get all the micro-frontends variables, micro-frontends available. The micro-frontend discovery service will call a database that collects this information. And then if there is canary release, it will provide, let's say, the select configuration. Otherwise, it will provide the configuration. That's it. Very simple, as you can see here. Now, with Matteo that is working in AWS like me, we started to think, okay, that's great, but we cannot delegate everything to our customer. This is a problem that everyone has, and it's quite common. Let's try to build something for solving this. So we are currently working, we are not far to release the first version. What is called in AWS an AWS solution. An AWS solution is an open source project that you can, let's say, fork from GitHub and customize in the way that you want. But if you don't want to do that, you can go in this page of AWS solution and select the discovery front-end discovery solution. That basically you click deploying your AWS account, and you can immediately have an endpoint that allows you to do exactly what I described. How it works behind the scene, we created two sets of APIs. The first one is an API that basically is fully serverless, because we thought, okay, we want to be as cheap as possible for our customers. So you can deploy that with serverless, you pay for what you use. Therefore, if you don't call the Lambda function, you are not going to have a cluster there 24/7 and you're going to pay with that. So this API basically will be called by the application shell towards the API gateway, and basically we return the schema that I described before. The data are stored inside DynamoDB. So the following question was, okay, how can we move from the data that we have into DynamoDB? So we created another set of internal API, and we wanted to create these internal APIs for one single reason. We don't know what CI/CD you're using, and To be honest, should we care? Probably not. It's just let's say an additional service to simplify the deployment of your system. And therefore, we thought, okay, let's create an API. So from any CI, from GitHub Action to GitLab pipelines to SQL CI, wherever you want to use, you can call this API and just say, I have this new version of Micro-frontend. I want to use a canary release strategy, adding a 30%, a 10% increment every minute, and we will take care of creating the logic behind the scene that every minute will increase by 10% the traffic that you want to see towards that micro-frontend. And hence why we have this database that basically will contain all the things. Once again, this will be documented. It will be, let's say, available to everyone. You can fork it, you can do whatever you want, and it will be available. We are aiming for end of Q1, early Q2 of this year. And there are a few already customers that are looking into it, but I believe this will be quite an interesting deployment for the front end. So let's try to recap what we have seen here. So we have seen that using the JSON schema, we are able to decouple the logic from the application shell. So we start to have this, let's say, composition that is handled by the framework. We can apply this idea everywhere, and is a very simple and native, let's say, web standard way for doing things. Thanks to the JSON schema, we can unlock quite a few opportunities here. Imagine, for instance, now, I don't know how you are using Module Federation or Single SPA, if you're using them, but imagine that you need to point to different environments. And today, I have seen, let's say, fork in the logic of the web configuration, or having a web config for dev, one for staging, one for production, and so on and so forth. But what if you can do the discovery of your system dynamically? That would be a very nice thing, because it simplify your journey. And also it opens up new developer experience. If you think about that, it's just a JSON schema. You can create a tool around that, how you can generate, and it's completely coupled inside your organization practices. That is, in my opinion, a great plus. Last but not least, we are reducing the blast radius of potential bugs in production. That, for me, especially because I work in live broadcasting, I know how painful it is when you deploy something in production, and having a safe mechanism for developer where they can deploy their new version of Micro-frontends, easing the traffic based on whatever rules you want. It could be that you want to also enhance what we are planning to do, adding the browser. In my previous implementation, I allowed the developers to say, I want to deploy this Micro-frontend in Switzerland, and I want 5% of the traffic in Chrome only. All the rest of the traffic will be on the previous version. This granularity allows a great feedback loop and reduce drastically the amount of bugs that you can introduce in production. That's all I got. I hope that you enjoyed the presentation. I'm more than happy to answer any question. Thank you very much for having me.